All right, it's Monday night, the 4th of August, 2025. I am running a test of the area phenomena detector system that I articulated on a Ross Coulthart YouTube question and answer video, where they were talking about how anomalous craft of whatever type can be detected using radio interference if you have certain kind of equipment. And I suggested that many of us amateur astronomers have the capacity to monitor the sky, because I have seen peculiarities in the sky due to moving craft, but that was incidental to doing deep sky studies. None of them did any radical changes in vector or direction that would indicate to me that they were unusual type craft. Mostly satellites, some meteors streaking across, some satellites moving fairly quickly, and some satellites moving fairly slowly. Some as groups I saw one group of 3. In this instance, what I recommended, because the moon is known, if you know the time and the date, you know the position of the moon in the sky, and you know your own longitude and latitude, it gives an indication of where you actually saw something fly in front of the moon. Now, I'm not talking about things flying near the surface of the moon. I'm just talking about things that are atmospheric. We don't have enough resolution and magnification in our scopes to accomplish that unless something were extremely large. We got a bit of a problem right now, though. You can see the moon is out of focus. And the reason for that is it's behind some branches and leaves, which causes a certain degree of diffraction. So I haven't been able to set a precise focus. So what I'm going to do is I'm going to spend a little bit of time focusing as soon as the moon clears. It's post-culminatory right now. As soon as the moon clears the trees, I'll finalize the focus. And then what I will do is do what I recommended was 15 minutes of recording. And that's what I'll do. This will just be a prototype. And you can hear an aircraft flying over, but it is not going to fly in front of the moon. I have seen birds. Oh, we just saw something move across the moon there. I have seen birds, and I've seen aircraft silhouetted against the moon. We did just see something fly in front of the moon, but it was very quick. I'm surprised that we were able to see anything so soon. But anyway, what I'm going to do is pause recording at this time. And then I want to get to do some astro later in the evening. There are high thin clouds, but I did want to prototype this approach to being able to detect unusual phenomena. Now, I did recommend that birds flying in front of the moon might be very interesting to capture in and of themselves, especially for bird watchers. We did just see something cross the face of the moon. It looked quite shadowy, it looked long, but it was very, very quick, and I doubt we'll get any resolution on it. But give me a moment. I'm going to play with the focus a little bit. You see the shutter speed I got set up, 1/4000th of a second, and the gain is at 24 decibels. So that gives you an idea of how quickly we should be able to capture frames. And you want to capture this data plus the time and date, roughly, because I don't have a watch on me at which you start and stop recording. So this is just an introduction, and now I'm going to go and play with the focus and find out roughly what time it is within a minute before I begin this actual 15 minutes of recording anything silhouetted against the moon. And it's now an 8-day moon, so it's roughly about 60% of the moon is now illuminated and facing towards the Earth. It's now 9:25 on my microwave's clock. Could be off by 1 minute either direction. I do try to set it once in a while using a sat clock. Now the moon looks pretty bright on the screen, which is I'm using the Sony Handycam. It looks fairly bright. I don't want to play with the settings right now. I just want to go ahead and just do a quick check. Now, I've already seen something fly across the moon, which I noted in the earlier, and then when I was coming back to set up the camera, something else moved across the face of the moon. Probably was a local insect. Remember, anything that can pass before the moon could be detected using this method. So it could be near or far. What we're looking for something that gives definition. So either by the morphology or the actual behaviors of whatever it is, we can get a rough idea as to what we have just captured on the video. So as I said, it was roughly 9:25. I'm going to let this camera run till about 9:40, 20 till 10. And I want to point out the equipment is, what I'm using is my portable scope with a Revolution 2 imaging sensor. It's fairly inexpensive. For about $250 to about $300 you can purchase what I got. I'm using a Sony Handycam, but you could use a cell phone just as well. You want to go ahead and define how long you're willing to image. Roughly, I speculated 15 minutes, but anything from 5 to 15 minutes should be fine, just to get a sampling. Now, if you can imagine, astronomers all over the planet, before they actually go out and do whatever deep sky they're doing, set up something like I have here rigged. I'm using an f4 newt, but I do have the dew cap on the front, and I've removed only about 1.5 inches of aperture. So we're not exposing the full light of the paraboloid 6 inches or 150 millimeters to the moon. We're only exposing maybe about 1.5 inches of aperture off axis from the, you're seeing an insect now, but that's on the screen. So that should be easily detectable. That's right on the display that comes with the Revolution 2 imager. Revolution 2 imager comes with about a 4 by 7 inch screen, which is squeezed down in order to get the aspect ratios correct for astronomy. The original system was set up basically for security monitoring, and then they adapted it and gave it an interface, etc., etc. So you could hook it up to your telescope. It mounts as an 1.25 inch eyepiece would mount in your scope. The scope I purchased got a field flattener, which was quite expensive, a couple $100, plus the f4 El Quattro from Skywatcher cost about $600. And the mount is most important because it's a tracking mount. It's about $1,500. So I've got about, let's say, a little less than $3,000 invested in the scope itself. You don't really need to have that expensive a scope. As I said, I'm cutting the aperture down to about 1.5 inches. You could easily get by with, let's say, a 3 inch. I would recommend a fast refractor like a short tube 80 or something comparable. It doesn't have to be semi-achromatic or a fully achromatic scope. So you could probably set yourself up with a lighter mount, because this one is a little heavier. For something like $2,000, you could be doing what I'm doing right now, monitoring for flying objects, near or far, flying across the face of the moon for 15 minutes of time, and then posting it up on your YouTube channel if and when you capture anything of interest. And I am going to post this up strictly because this is the prototypal effort to see what might turn up. We've already seen one thing very quickly transit the face of the moon. I've seen an insect, I believe, on the screen here, and possibly one in the sky in the direction of the moon. So I'm going to go ahead inside now and let this thing run, and then in 15 minutes, which would basically be 20 minutes to 10, I will terminate it. And the idea is I will post this up as an example of what you can do. Once again, if you have thousands of astronomers all over the planet monitoring the roughly 20 to 30 arc minutes of sky, which you see here, and something unusual passes, you will have an image of it, you will know the phase of the moon, you'll have the date, you'll have the direction in the sky, a lot of information you might need to have in order to characterize whatever phenomena passes before transits across the face of the moon. A lot of that information will be there, and a lot of it is actually stored as metadata whenever you do a video. Now, I don't think my video camera's been set up with the proper time and date, so I would not use that. Once again, I've recorded on the microphone of the camera the initiating time at which I started monitoring the moon, and I will let you know roughly what time it is when I terminate it. So go ahead, listen to the insects creaking around us, watch anything that flies in front of us. I'm going to go check the time. Probably heard my footsteps on the way up. It's now about 9:34. We're into this for the last 9 minutes. We have 6 more minutes roughly to capture the moon. I would point out I am using a deep sky filter, which adds some color to the moon. The moon is also very low. It's no more than 20 degrees above the southern horizon. And that's because we're in the summertime, and about sky dark, the moon, in the summertime, the moon is very low with respect to the solar position, which heads distinctly to the north and to the west at sunset, especially at roughly 45 degrees north latitude that I'm currently at. I am not really pleased with the focus. Oh, there was another insect that flew in front of the moon. Not really, and that was before the objective lens, the mirror. It wasn't on the screen here. As I was about to say, if I can remember what it was, I am only doing this once again just to prototype the approach. The most suspicious object I saw was one early on that looked rather tubular, cigar-shaped, but it was so quick. Now, I am running 6-second stacked exposures. You may not want to do that. You may want to actually just do single frame exposures instead of stacking them. Stacking them helps you eliminate background light in the sky, so it brings out deep sky studies. But what we're looking for here is the highest resolution possible. But I am not going to play around with my Rev 2 system. I'm just going to leave it normally set up. It gets a little complicated. The scope I'm using is portable. It has to come out of the garage. I have to carry it out. I have to set it up. I'm set it up on the lawn, so I make sure I get a view of the moon to the south. Otherwise, if I set it up on the, excuse me, underneath the eaves of the garage, I wouldn't be able to capture the moon. It makes for a very complicated 3-star alignment too when I do park it there. But the virtue of parking it there is that I can leave it out if the weather is supportive of it. Once again, I would like to get a sharper image of the moon. Unfortunately, this is a fast Newtonian. Like I said, however, I did choke it down, so the focal ratio is probably somewhere around f15 to f20. It should give a fairly sharp image, but the real problem is the moon is so low, the atmosphere is disturbing the focus. Some features to look for on the moon, if you're interested, are the Maria. This one here kind of looks like bee, queen bee. One of those is Procellarium, I believe. Oh, there was another insect. Tranquillitatis. There's some craters visible on the moon. You can see some rays from impact craters, or probably from comets cause those rays. I haven't really looked into it that deeply. You see some deep craters, some shallow craters. You see, we should be seeing Plato. That's one easily recognizable. It's actually a walled plain, like Grimaldi. Grimaldi's further towards the full moon end, which would be to the east. The part of the moon that's illuminated now that you can't see it because it's drifted a little bit and I didn't image it precisely. That part is facing the west towards the sun. So it won't be until after the full moon that the disk to the east begins to reveal itself. You can do this practically any time of day or night. It's tougher during the daytime, but you could set things up to accomplish it. Any day, any time from about 1 day after the new moon to 1 day before. So there's only 2 days out of the 28-day lunar cycle that someone couldn't get out with their scope and image like this. So once again, we've seen several things already fly in front of the moon. Most of them were insects. I have actually, as I mentioned earlier, I have actually imaged aircraft flying before the moon. They did resolve very nicely, but those are commercial jets flying at about 600 miles an hour, and they're probably, given the low position of the moon right now, such a plane would probably be about 5 or 6 miles distant. We're using what I consider to be 75x magnification. We're roughly getting 20 by 15 arc minutes in terms of the amount of apparent size of the sky. So 20 arc minutes is about 1/3 of a degree. We're not getting the full 30 arc minutes of the moon in, because you can fit 2 moons roughly in a degree. But it's a start, and it's something anybody with astro equipment and real-time imaging could do, and you never know what you might turn up. I'm going to go and check the time, and if it's 20 minutes to 10, we're going to knock off with this first prototypical view of the moon according to what I wrote up for the Ross Coulthard question and answer cycle that I recently watched. So okay, according to the microwave clock, it is now 9:39. If you have any questions about this approach to things, I do recommend you leave some comments under this video, which I expect to post up tomorrow. Now, I have in the past captured things transiting the field of view during imaging, and I will try to see if I can turn up an example of that. But that was basically deep sky imaging. It was not the moon. These were luminous objects, frequently meteor trails, sometimes satellites, and there are ways of distinguishing them. Meteor trails are kind of chaotic and with knots and obvious telltale signature in their luminosity. Satellites may have a rhythmic pulse to them if they're rotating, or they can be steady in terms of their luminosity, especially when they're only moving over, let's say, 20 arc minutes of sky, 1/3 of a degree. So with that, I am going to say, seize the night, carpe noctem. You never know what you might turn up if you're out looking at the night sky. Yep.